All right, welcome. My name is Ryan Holger with National Excelsior Company and Temperature Equipment Corporation. I am the technical trainer over here, and I do double duty at both companies. This week's topic for our webinar is Observer Communicating Control Systems with Zoning. So we're going to spend a lot of time talking about zoning in general for residences, and specifically what happens in an observer zoning system. All right, so first of all, let's talk a little bit about Observer, just so you know what that is before we talk about how to use it in a zoning application. First off, it's a high-resolution screen display. It's a communicating thermostat, or as the manufacturers like to call it, it's a wall control. They don't like it when we call it a thermostat. They want to separate themselves from that arena. But it is in fact a thermostat, but it does communication, so it does not use your normal, Y1, Y2, W1 type wiring. It actually communicates over a cable, and then that communication sends packets of information that ask for cooling, ask for heating, etc., and the equipment stages based on those requests. There are some significant benefits to that, which we'll talk about here. The first is we have the ability from the thermostat to configure and control different airflow rates with variable speed fans. So we can slow down the blower for a dehumidification call. We can change speeds from the end user's perspective. They can pick low, medium, or high fan speed for continuous ventilation, or they can just pick auto and let it do its own thing. We also know specifically which piece of equipment we're communicating with and hooked up to, and how much airflow those particular pieces of equipment want to see for heating and cooling at the various stages. So all that kind of happens on its own. There's nothing special you have to configure. There's no dip switches. There's no jumper plugs. Nothing you have to change on the fan motor. The thermostat figures out what it's working with, what kind of equipment, and automatically configures all of its appropriate airflows for the different modes. You also get advanced diagnostics with a communicating control, which means all those error codes that you get on condensing units and heat pumps and furnaces, all those blinking lights at the circuit board, instead of going to those pieces of equipment and counting blinking lights, you can go right to the thermostat control on the wall, and it'll tell you right there in plain English in text what exactly the error code is. Right, so it'll tell you whatever, error code 34, igniter fault, or whatever the error code is. The other nice thing about having a communicating system is that every single project, no matter how many stages of heating and cooling, and no matter what accessories you have, it only requires 4 thermostat wires total. So you could have 2 stages of heat, 2 stages of cooling, a humidification signal, a dehumidification signal, whatever. It's all going to be done over the exact same 4 wires. Right? So we'll talk about that a little bit more as we go. And there's also other cool features that you'd expect on high-end stats, like smart recovery mode for energy savings and service alerts and those kind of things. This is what a typical wiring scenario would look like for an observer communicating system. So in that first column there, we have the observer control itself, and it has 4 terminals on it. Actually, it has 6 terminals, but for right now, we're going to ignore S1 and S2. That's an optional sensor, and we'll talk about that in a little bit. But you got the first 4 terminals there, green, yellow, white, and red. White and red are 24-volt power that it gets from the furnace circuit board's transformer in order to power up the thermostat. Green and yellow are the communication cable, so everything else is happening on green and yellow. So if it wants to call for fan, or it wants to change the fan speed, or it wants to call for 2 stages of heat instead of 1, or it wants to call for cooling, or whatever, it all happens over the green and the yellow wire. The thermostat makes a request over the green and yellow wire over to the furnace circuit board, and the furnace circuit board turns on the appropriate outputs. So stage 1 of gas, stage 2 of gas, etc. Humidifier. The humidifier, as you can see, is actually wired to the furnace, not wired to the thermostat. So that helps you out with wiring distances, because generally the humidifier is directly above the furnace, and wiring the two together is very easy. Same with an air purifier. If you choose to put one of those on the unit, we can enable that off of the furnace circuit board. Then you have the outdoor unit, and he also can be a communicating piece of equipment. So you have those same 4 wires that go from the thermostat to the furnace, then go directly out to the outdoor unit as well. Same kind of deal. White and red are 24-volt power, and green and yellow are the communication wires. So the thermostat talks to the furnace talks to the condensing unit. If the thermostat wants cooling, he'll tell the furnace to turn on the fan, tell the compressor to come on outside. Everything's happening over those same 2 wires. If you guys have questions as you go, I probably should have mentioned, just type them in that question chat box down in the bottom right-hand corner of your screen, and I'll do my best to answer them on the fly as we're going along here. Unless you give me a nice, good stumping question, then I might have to get back to you later. So do your best to stump me if you could. This is what those wiring terminations look like. So down in the bottom right-hand corner of the screen, I'll see if I can get a little highlighter pen thing going over here. Down over here in the bottom right-hand corner of the screen are the terminations on the thermostat, and these four are the ones we're using for power and communication. R and C are power. DX1 and DX plus and DX minus are the communication. S1 and S2, like we said, that's for an optional remote sensor. Those four wires are going over the four wires in the cable, your thermostat cable, over to a plug at the indoor condensing unit. So it's pretty much that simple. So there's different wire. Let me clear off those little things. All right, there's different ways you can wire this up. The first way would be what I'm going to call an all-communicating system. That means the indoor unit, which is a furnace or a fan coil, and the outdoor unit, which is an AC or a heat pump, are all communicating type systems. So they have a circuit board in them with those four-wire cable connections, and they can be a communicating piece of equipment. In those cases, you'll do, like I said earlier, you'll run four wires from the stat to the furnace, and those same four wires will then daisy chain out to the outdoor unit. However, if you have a day and night condensing unit that's communicating that is a two-stage unit, you actually only have to run two wires out there. I know it seems a little bit counterintuitive, right? I got a single-stage unit, I need four wires, but a two-stage unit, I only need two wires, and that is in fact correct. That is because that two-stage unit has a transformer out there to power up its own circuit board for other reasons, so it doesn't need the 24-volt wiring to go out to the condensing unit from the furnace. So in the case of the single-stage unit, he has to steal power from the furnace to power up his circuit board. In the case of the two-stage unit, there's already a transformer built into the unit, so it already has power. So it's all the more reason to use a two-stage unit when you're selling high-end systems. I think most of you guys kind of get that. If you're selling a variable speed furnace on comfort and all of that, you probably are also going to want to talk about two-stage equipment with your customer. But it does make it easier to install because, as most of you know, existing installations already have two wires in the wall, not four, so it's easier to use a two-stage unit in these cases. So that would be an all-communicating system, and that's pretty straightforward, I think. You need either two or four wires out to the condensing unit. If you're pulling a new wire, just always pull four. It's pretty easy to think about it that way. You could also have a system that has a communicating indoor unit, but a non-communicating outdoor unit. There's various reasons why you might have this. Maybe somebody wants to go with the top of the line, furnace, variable speed communicating furnace, because they feel in Chicago they get a lot of run hours here in the Midwest. But maybe they feel, I don't have a lot of cooling hours, so I'm just going to go entry level on that piece of equipment. You could do that. You still have the four communicating wires that go from the stat to the furnace, and then you have two wires that go out to the condensing unit. Those are not the communication wires. Those are just your regular common and Y1 signal. The furnace has an extra relay built into it that it can use to turn on that condensing unit. So the furnace gets a request from the stat for cooling. The furnace actually engages Y1 and C to turn on the condensing unit. You could also have a scenario where you have two-stage non-communicating equipment. This might make a little less sense to me because if you're going to go higher end with two stages, why would you not use the communicating type? But nonetheless, you might have that scenario. Or maybe somebody owns an existing, Lennox or Carrier two-stage condensing unit that's like 3 years old, but you're giving them a new furnace for this project. They're probably not going to throw away their 3-year-old Lennox condensing unit. So they're probably going to want to keep that. In those cases, what you can do is you can get a daughter board. That's that NAX part number you see on the screen there on the bottom. You can get a daughter board that allows more relay connections, if you will. So the thermostat talks to the furnace, it does all that communication stuff I had mentioned. That furnace also, over the same communication cable, talks to the daughter board, and then the daughter board has your normal relays, right? So it has 6 relays in there, so it can turn on 2 stages of heat on the heat pump, 2 stages of cooling on the AC, that kind of thing. So you can do that if you wanted to. I wouldn't recommend you sell it that way out of the gate, but if they have a 2-stage unit of some other brand or some older 2-stage unit that they want to keep, that's the way you'd make that work. The third scenario would be you want to use an observer control on a system that has no communicating equipment, no communicating indoor and no communicating outdoor. Once again, I probably wouldn't sell it this way because the whole benefit of the observer control is the communication and its ability to self-configure the furnace and AC and get all that diagnostic information from those units. So if you lose all of that, it's basically a regular thermostat. So it's not that exciting to do it this way. But if you needed to, you could certainly do that. This is how you'd wire that up. You use that same daughter board, and you have all the relays on there for Y1, Y2, W1, W2, and fan. If you guys have any questions, type them in so you can get them answered here on the fly. Some of the things that will happen when you allow the observer control to self-configure in a communicating system. So the control, when you power it up, it'll start interrogating anything on that 4-wire communication cable and start asking them, hey, what are you? Hey, what are you? Hey, what are you? Right, and those pieces of equipment will tell the stat what they are. Yeah, I'm a furnace, 80,000 BTUs, variable speed, 92% efficient, blah, blah, blah. Yeah, I'm a condensing unit, 2-stage, 3-ton, blah, blah, blah. It'll tell it its model numbers, it'll tell it its serial numbers. Basically, the thermostat now knows everything about that indoor or outdoor piece of equipment. Based on that information, it can do some of the configuration stuff on its own. For example, if it sees it has a 3-ton outdoor condensing unit, it'll tell the furnace which fan speeds to use for that 3-ton condensing unit. So it'll say, okay, based on whatever, 350 CFM per ton, for a 3-ton condensing unit, I need 1,050 CFM at full cooling. I need whatever, 700 CFM at single stage cooling. So it'll do all that for you without you having to think about it or configure it or anything like that. It'll also help you configure control for accessories. Now, it's not going to automatically recognize your humidifier or something like that, but it'll ask you, hey, you got a humidifier? If you click yes on the screen, it'll configure itself for humidifier. It'll put all the humidifier set point tables and everything into the stat, and it'll be ready to go and ready to energize that humidifier off of that extra relay in the furnace. Same thing for, filtration and air purifiers and all that kind of stuff. All right, so typically the things that are automatically identified by the control through the communications, for the most part, it's variable speed equipment, so variable speed furnaces and fan coils, whether they're 80 or 90% or fan coil. Those are probably going to be communicating pieces of equipment, so we'll be able to talk to those. Sometimes on a fan coil there is a communicating electric heater, sometimes not. And then the outdoor equipment could be communicating single or dual stage equipment. If you have non-communicating equipment, not a problem. Like I said, we just got to think about how we're going to wire it and whether we need that daughter board or not. And as you're going through the screens, if it doesn't find an air conditioner, so it finds the furnace, configures it, doesn't find the air conditioner, the screen will ask you, hey, do you have air conditioning? And if so, how many tons? It wants to know how many tons because it wants to know how to configure the airflow for you. Do you have a humidifier? What kind of filtration do you have? So it'll ask you those questions and prompt you through the process if it can't find certain pieces of equipment. Lots of other cool stuff we can do. I'm not going to spend a ton of time on the stat itself because I want to talk about zoning mainly today. But the stat itself can have notification alerts with the dealer contact info pop up. You can have service reminders, dirty filter reminders, those sort of things, and other stuff you might expect on a higher end stat. This is what the main screen of the stat looks like for the consumer. It's fairly intuitive and easy to use. Along the top bar of the stat, you have your normal basic data, time, date, outdoor temperature. Right in the middle of the screen, in the biggest font, you have the indoor temperature that it's currently measuring in the space. If you want to change set points, it's on the bottom right. You can press the heat button or the cool button, and little arrows will pop up so you can go up or down on those set points. And then obviously you can change the fan mode from auto to continuous, and you can change the cooling mode from heat to cool to auto to off. Normal stuff that you'd expect. If you hit the setup menu, that's where you can go do your schedules. You can do advanced settings there from the service end if you want to change airflows or something like that. If you choose to use one of those optional remote sensors, which you can certainly do, right? So maybe they got their thermostat location is in the dining room, and pretty much nobody uses their dining room. That's been my observation. I certainly don't use mine. And you want to sense temperature in your family room where you basically spend all your time. You can leave the thermostat where it is and all of its wiring to the equipment and leave all that alone if you want, and then put a remote sensor anywhere else in the house that you pick. And then once you do that, it'll automatically recognize that sensor, and when you're configuring the stat, it'll ask you, hey, do you want to use the local sensor inside the thermostat? Hey, do you want to use the remote sensor, or do you want to average the two of these things together? Right? So you can kind of do that a little bit to get a little better comfort in the areas you care about, but don't confuse that with zoning. it's going to make wherever the sensor is comfortable, right? It's not going to make every room comfortable, which is the purpose of zoning and what we'll talk about here in a minute. The last sensor that would really be involved on a non-zoning system would be the outdoor air temperature sensor. If you have a communicating condensing unit or heat pump, this sensor is built into that unit and you do not need to do anything. It'll automatically send the outdoor temperature readings through the circuit board of the condensing unit to the furnace to the thermostat over that communication cable. The one thing you got to pay attention to, or I guess the two things you got to pay attention to, one, if the condensing unit is located in a quote-unquote bad location, meaning that the sun is beating down on this thing all the time, you're going to want to relocate that sensor, right? Put it on the other side of the condensing unit, put it on the other side of the house, ideally the north side if you could, and get it out of the direct sunlight so you don't have false readings all day long. If you have non-communicating equipment, you still want to get that outside air temperature reading, so you can then wire that to either the furnace circuit board or to that daughter board that we were talking about earlier if you have non-communicating equipment. And at that point in time, you want to try to put it on the north side of the house as well, because in our hemisphere, the north side of the house basically gets almost zero sunlight. That outdoor air temperature sensor, just for point of reference, is used for multiple things. It displays the outdoor temperature reading. It can be used to reset the humidity set point so windows don't fog up. It can be used for dual fuel changeover on heat pump gas furnace systems. It can be used for lockout of compression when it's really cold. So there are numerous reasons why you want to get an accurate reading on that sensor. Let's talk a little bit about zoning in general, and then we'll talk about the new observer zoning system and how it kind of fits in. So the first thing on zoning here at Excelsior, you guys probably know, and many of you have bought Honeywell zoning systems from us in the past. We're not going to stop selling Honeywell zoning systems. We like Honeywell. There's nothing wrong with Honeywell. We're going to continue to use it. It's a good product. There's many benefits to it. However, we've had many cases, especially in the past 3 years since we've been really doing modulating gas furnaces, that we've had issues where people have tried to apply Honeywell zoning systems to a modulating gas burner system on a furnace, and you just can't do it. I mean, you can make it work, but it's not going to modulate the gas furnace correctly. You're going to basically end up with like a two-stage unit, which defeats the purpose of buying modulating gas. So in order for you to have a day and night furnace or any ICP furnace with a modulating gas valve, you need to use the observer control. You can use that as a regular control, or you can use it on a zoning system now that we have observer zoning. So that's really the main place we want to target this observer zoning panel, is on systems that have modulating gas furnaces. Now with that being said, in my opinion, and I've been doing zoning for 17 years, if you're going to do a zoning system, you want as many stages of heating and cooling as you could possibly get your hands on. Because a lot of times you're going to have only one or two zones calling, and you're going to want to stage down as far as possible. The modulating gas furnace gives us that best option. We can basically go from 40 to 100% capacity on heating in 1% increments. So I can run it at 40, at 41, at 42, at 57, at 93, at 100% capacity. The more stages, the better when you're using a zoning system. So I really would want to push you into the modulating gas furnace if you think you're going to add zoning to a house. So it'll self-configure just like we had mentioned before. You get all the alarm codes and all that great stuff. There's some really good benefits to using this observer control versus a standard zoning panel. So previously in the past, you had to pick when you wanted a modulating gas furnace. Do I want to use zoning, like Honeywell type zoning, or do I want to control the modulating gas burner? You had to pick one or the other. You couldn't do both. Now with the observer zoning, we can do both. So some of you probably have seen these slides when I've done Honeywell classes in the past. Just kind of get it out there with the zoning. Most people are uncomfortable in their homes at certain times of the year. We say certain times, I would say most times. We say 67%. I would say it's probably even more than that. Those are the ones that just admit to it. And if you have more than one person in the house, certainly somebody is uncomfortable, right? The number one complaint people have after moving into their new house is that they have uneven temperatures in the house. Upstairs is hotter than downstairs. The basement is freezing. The family room with all the glass windows is always cold, or it's always hot. It's never the same as the rest of the house. You guys have all heard the deal, and you've all come up with ways to Band-Aid it and help make it a little better. And some of you have even used zoning to make it better in the past. The same study that we were given through the Honeywell folks, which granted is 8 years old now, but people are people and they don't change that much. 4 out of 10 people who were offered a zoning system actually bought the zoning system. The majority of the time when zoning is not sold, It's because people don't even know that there's such an option. Now, you don't have to get crazy with it. You don't have to start talking about zone dampers and bypasses and modulation and all this weird stuff. All you got to do is ask people, hey, I know it's really hot upstairs in your house and it's fine downstairs. Would you like to have a thermostat for both upstairs and downstairs and get the temperature you want for both? That's it. That's the whole pitch. You want 2 thermostats for your house so both areas are happy. Or if they have other problems, do you need 3 thermostats because you got these other rooms, or 4 or 10 or whatever their house is. You just got to offer them more thermostats to get the exact temperature they want in different spaces, and how it works behind the scenes and what ductwork you got to do. You can talk to them about that after you've already kind of explained why they want it. So most systems, when we zone them, end up being a 2-zone system, upstairs and downstairs. We certainly do plenty of systems that are 3, 4, 5, 6, 25 zones, depending on your McMansion, right? But 2 zones is very common to solve the upstairs, downstairs complaint, right? Your thermostat's downstairs at 72 degrees. Everyone's perfectly happy. Upstairs, it's hot and it's roasting. All right, so you want to put a second thermostat up there so that area can call for cooling. You can't just move your thermostat upstairs because now your downstairs will end up being freezing. You'll get 72 upstairs, but it'll be 68 downstairs. So you want to use zoning so you can control how much air goes into the upstairs and the downstairs separate from each other. All right, so we end up with a perfect scenario. 2 thermostats, both of them meeting set point. Everybody's happy. Yay. The other thing to think about too is zoning is not an abnormal, weird thing that people don't understand. Most people have zoning in their cars right now. I think the last 3 cars that I've owned have all had zoning, and my minivan, which is from all the way back in 2006, actually has 3 zones in it, right? People expect zoning. The husband and wife want different temperatures in their seats. They want different temperatures blowing out of the register on them in their car. The kids in the back of the minivan expect a different temperature, right? To make everybody happy, everybody needs their own thermostat. If cars can do it, there's no reason you can't do it in your house. You probably spend more time in your house than your car anyway, unless you're involved in sales. Then maybe it's a little different. So a normal zoning system, here's what we would do. And this example here is with a Honeywell zoning panel, right? So we'd pick our zoning panel depending on how many zones we needed and how many stages of heating and cooling and all that good stuff. We'd pick our thermostats, right? And you could pretty much choose any thermostat you want on a Honeywell zoning panel. Although I will remind you that Energy Code in Illinois, residentially speaking, since 2009 has required programmable stats. So for all you guys that are buying non-programmable stats, just realize you're breaking code there. You select your dampers. You can do round or rectangular depending on the configuration of your existing ductwork or the new ductwork that you're planning on putting in. And then you need some way to relieve the pressure. As these zone dampers start throttling back, pressure is going to build up in the duct. You have to be able to relieve that pressure. The way we normally do that is with a bypass damper. So that damper opens up and dumps air from the supply duct back into the return duct to relieve the pressure problem. Now, granted, when using variable speed furnaces, the problem is minimized because a lot of times if you only have one zone calling for heating or cooling, you are at a lower airflow setting on the furnace anyway. However, it's still possible you have too much airflow, so you still do need to have that bypass. And then we also need a sensor in the discharge air temperature to protect the equipment, and we'll talk about that in a second. All right, so the way you decide to zone the house is different for every project depending on what the homeowner wants, but you got to divide the house into zones. There are numerous things that are going to dictate how this thing gets divided, right? There's the perfect scenario, which means you divide it up based on how the homeowner wants to be comfortable in different rooms. And then there's the realistic example, right, which is, well, what ductwork can I get to in this existing house, and where can I jam a damper in, and where can I not do it? So you're going to end up having some compromise of the number of zones and the zones that are grouped together. We'll talk about how to do that here. You got to size the bypass damper correctly, and it goes between the supply and the return duct, and we'll show you that here in a second. You got to install the dampers, then you got to install the panel and wire the dampers and thermostats to the panel. So the way to think about how to group the zones, very common scenario is by floor, right? Because a lot of times you got a 2-story house or even 3 stories or a basement, 1st story, 2nd story, and all those have different levels of temperature in them. So grouping them by floor is pretty much an obvious one that you're going to want to do. You may also want to group rooms, right? So you may have rooms that are bedrooms, right? You want to group those together, and maybe they can all have the same setting, and that's fine, versus grouping the places you hang out in the daytime, like the kitchen and the living room and that kind of thing. And then also think about what ductwork you have running where, and which ductwork you can easily change and which ductwork you cannot. So the best thing to do is kind of divide things into daytime and nighttime zones. Where do you live and where do you sleep? Those should automatically be separate zones. Then from there, that's 2 zones right there. Then from there, you can start zoning it further based on what you need. You may want to zone it differently a little bit based on the orientation, right? Especially if you have rooms that have a lot of glass and are going to get a lot of solar load on them, right? So you got that family room that's got that, solid glass wall overlooking the lake. Lucky you. That room probably needs to have a different thermostat than the other side of the house that has hardly any windows whatsoever and a different sun exposure. And then think about specialty areas. Home offices are a fantastic one that need their own zoning. Guest rooms, they don't need it, but it's kind of nice. When the mother-in-law comes to visit, she can have her own temperature, and you don't have to crank the heat up just for your whole house, just for her. Basement's probably another one, and then the bonus rooms above the garage. Those kind of areas probably do really good with their own stat. Here's a pretty common scenario. On the left is your upstairs, downstairs scenario. This is how I have my own house zoned. I would like to zone it further, but just getting access to the ductwork was a pain in the butt. So this is kind of my easy, lazy way out. I got upstairs is one zone, downstairs is another zone. The one on the right is a 3-zone example with the home office. People that work out of their homes would love to have their own thermostat in that office. And if you could do to provide that for them where they spend a good 10 hours of their day, probably a good idea. And like I said, you can zone it further beyond that. In terms of duct design, for the most part, all the branch ductwork you're sizing the same way you would have previously sized it, right? How much CFM do I need to get to this particular room based on its peak heating and cooling loads? The main supply ductwork, in the perfect world, you'd be sizing that for the overlapping peaks, right? So it may end up only being 80 or 90% of the full CFM of the system, the full CFM of the zones, right? So I may have, for sake of argument, 1,000 CFM for all my zones peaks, but the peaks aren't all at the same time of day because of the different exposures. So I may only need an 800 CFM furnace, 800 CFM supply duct, feeding 1,000 CFM of branch ducts, right? In a lot of cases, it's an existing system. You already have the ductwork, so you're not going to resize the ductwork unless it's problematic. So you may just be kind of working with what you have. All right, in terms of the bypass, his job in life is to steal air out of the supply duct and dump it back into the return duct. This is not an energy saving thing, right? So we want to avoid it as much as possible. However, as zone dampers are throttling back, we have to shove the air somewhere. We can't shove 1,000 CFM through a 6-inch damper. It's just going to be too loud and too problematic. So we have to have a way to relieve that pressure, and the way we do that is typically with a bypass damper. We could also do it with a dump zone, but that requires you having a room in your house that you don't care about, which most people don't have that room anymore. Ideally, the bypass damper, the takeoff for the bypass damper should be upstream of the zone damper takeoffs, right? That would be the most ideal scenario. Dick actually sends in a question asking if there's anything that should be considered when setting up a future zone, such as possibly a future basement finish out. Yeah, if you, in general, whether you have zoning or not, if someone tells you and you're helping them redo their ductwork in their house and they tell you, hey, yeah, we might finish the basement 3, 4, 5 years down the road, I would design the ductwork for that specific scenario, right? So, like in my basement, I finished it after the house was built. It's just the way the world evolved. So my basement is actually on the same zone as my first floor because it was too hard to redo all the ductwork. Because I'm not a very good sheet metal guy. I'm a good control guy. So basically, my basement gets whatever my first floor wants. However, if I was redoing the ductwork from scratch, right, what I would want to do is I'd want to have all my basement ductwork being fed off of one trunk run. So instead of having one big trunk that goes down the middle of my house and I tap a bunch of dampers off, a bunch of registers off of it, I would want one trunk run that goes to the basement and all my basement splices come off of there. Then I'd have a separate trunk run that would go to the upstairs and then a separate one for the second floor. Right? I'd want to have the ductwork lined up that way from the get-go instead of just randomly having it taken off the nearest point. In order to size the bypass damper, you got to basically just think of, well, what's the worst case scenario, right? So on this 3-zone example here, where the home office is the smallest zone, he's, in this case, 400 CFM, 1 ton. So it's either a really big home office or it's made out of glass. But for this example, we'll go that it's 400 CFM. The worst case scenario is that this 4-ton system, 1,600 CFM, is turning on because one little tiny zone wants cooling, right? So the other 3/4 of the air, 1,200 CFM, 3 tons, has to be bypassed, right? So we take the CFM of the total of the furnace, right? 1600 in this case, subtract off the smallest zone, I got to bypass the difference. That's basically how that kind of works. And then you would go look at the tables, or you would use your ductilator to see that 1200 CFM is basically a 10 or a 12-inch damper, depending on whose table you're using, or a rectangular equivalent. Setting the bypass is super easy. This is showing you an older style bypass with a counterweight. There are also ones that are spring-loaded, and there's also the new Honeywell one, which is really nice. You should check that out if you haven't already seen it. But in either case, it's all the same kind of setup. You basically open up all the dampers, and then you set the bypass damper so it's just barely closed. In the case of this counterweight one, you keep moving the weight on the rod until the damper is basically shut, but just barely shut. Like if you just had one more turn of it, it would open up, right, a little bit. So you set it so it's barely shut when all the dampers are open. Then you test it by telling all the dampers to go shut and just telling the smallest zone to call for cooling or heating, and it's verifying that that damper actually does in fact open. By the way, if your damper never opens at all, no matter where you set it, chances are pretty good you have a very leaky ductwork. You should think about sealing that up. And then you also need some type of supplier temperature sensor or discharge air temperature sensor to prevent problems. When we are cutting off airflow to the furnace and the air conditioner, it's possible that we're cutting it off. We're opening up the bypass damper, which means that I'm taking that 130-degree air and dumping it back into the return, which means I'm starting out with hotter air before the furnace even heats it up, and now it's 135, and it goes through again, it's 140. It's going to keep heating up, and the same thing with cooling, right? So what I want to do is I want the zoning panel to shut down stages of heating and cooling if the temperature limits get reached, so that way the equipment doesn't shut itself down. Because you guys probably know if the equipment shuts itself down X number of times, depending on the brand of equipment, it locks itself out, and then nobody gets any heating or cooling. So I want the zoning panel to protect the equipment before the actual equipment protection has to kick in. Right? So normally we say for a cooling system, we either use 45 or 50 degrees on the low end. If you get down to 50 degrees, I'm shutting off second stage cooling. If you get down to 45 degrees, I'm shutting off both stages of cooling. And then after a time delay, they can both run again. On the heating side, same kind of thing. We want the limit to be higher than the discharge air temperature setting that the furnace would normally see with full airflow. Right? So if I get, let's say for sake of argument, I set it at 140 degrees. If I get to 140, shut off stage 2 of heat. Excuse me, start off stage 2 heat. If I get up to 150, shut off both stages of heat. You need to do this on pretty much any zoning system to protect the equipment, unless you have a communicating zoning system and they can kind of stay in sync with each other. A little different discussion there. The discharge air temperature sensor ideally would be downstream of the bypass takeoff, and not in some corner somewhere, in the main airflow where it's going to see air movement. Don't put it in a corner, don't put it on an elbow, don't put it on a bend. I know in the real world where you got an evaporator coil, a PLEM, and a bunch of takeoffs, that makes it a lot harder, but try to get it in a place that's actually going to see air motion. In the perfect world, it would be 3 to 5 duct diameters downstream of all takeoffs and all elbows. I know in the real world that's probably never going to happen on a residence, but that's kind of your goal. All right, if you guys have more questions, type them in, please. I'll try my best to answer them. So we talked a little bit about Observer, talked a little bit about zoning. Now let's talk about the two of them together. So new for this year, and I say new, back at the end of spring, early summer, the factory released this new product. As you probably know, here at Excelsior, we like to wait a few months for the rest of the country to try stuff before we do. That way, if there's any weird bugs and kinks that need to be worked out, it's not our problem. So as of like a month or two ago, we started stocking this system as well. So we figured it's a good time to have a webinar to kind of educate folks about it. So the first thing is you're using the same Observer wall control that you use on a single zone system. It can be used on single zone or on zoning. If you have one on the wall already, you can use it for zoning, but you do have to upgrade it to the most current version of software. That can be done via laptop and USB cable. Right? You can on your laptop, or even a regular computer for that matter, you can download the updated software, put it onto a USB stick, and then through a cable and a USB stick, you can upload it into the thermostat itself. Don writes in a question, all the room sensors I've installed don't have 4 terminals, only a R and C, and can't get them to get them registered. I'm not sure what kind of zoning system you're talking about, Don. If you're talking about Observer, I'll address that here in a second. And we'll talk about how that wires up. Okay, so the Observer zoning panel can handle up to a maximum of 6 zones, and you could theoretically have 3 dampers per zone. Do not be confused and think that 6 times 3 means you can have 18 different control points in the house. That is not accurate. You can have 6 zones, right? So 6 different thermostats and or sensors on the wall. The 3 damper thing, ideally each zone would only have 1 damper because that would be the least expensive thing for you to install. However, if the ductwork is existing and you already have multiple trunk runs going to a certain area of the house and those 2 areas are going to be 1 zone, you can have 2 or 3 dampers off of that 1 zone. They will open together, they will close together, they will do everything the same based on what their 1 thermostat asks for. So you can have up to 3 dampers doing the exact same thing on 1 particular zone, but a 6 zone maximum. The zone panel is a communicating device, just like the furnace, just like the AC, just like the Observer stat. The panel communicates on those same exact 4 wires. The room sensors, there are older ones that you can use that are 2-wire, which I think is what Don was mentioning. They're a thermistor sensor, so they basically get a voltage pass through them, and then based on the resistance of the voltage drop, based on temperature, you would be able to see that temperature reading. The new ones, which are the ones in the bottom right-hand corner of the screen with that zone part number down there, those are a 4-wire communicating sensor. So they're kind of like the Observer control, except there's no LCDs that display on them. And we'll talk about where you can use those in a second here. There's also dampers, as you might expect. These are power open and power closed dampers, which means they are 3-wire dampers. If you have an existing zoning system that is a 2-wire zoning system, which means you're going to power it closed and spring it open with a mechanical spring, you could still use that with this zoning system. But if you're buying new day and night dampers, from the factory out of the box, they would be 3-wire and you'd be power open and power closed dampers. Like I mentioned before, you have to have a barometric bypass damper or set up a dump zone. I'd go with the barometric bypass just because the chance of you having a room to dump it in that you don't care about is pretty low, because pretty much everybody's got a finished basement these days. The outdoor temperature sensor is built into the condensing unit. However, if you have a non-communicating condensing unit, you can order the outdoor temperature sensor. And then just like the Honeywell zoning, we need a leaving air temperature sensor just to make sure we babysit that and don't get things out of whack. If you want to use your own dampers, you can certainly do that. And then you would just get actuators from day and night and put them on your own dampers. We'll talk about that in a second as well. You can use these new 4-wire communicating sensors for the individual zones, or if you want, you can use the main LCD stat in any of those zones. And I'll show you some pictures of that in a second here. But that main stat in the bottom right-hand corner can be used as zone 1, 2, 3, 4, 5, 6, or you can just have one in zone 1. You can mix and match, and I'll show you some good examples of that momentarily. Pretty much everything is 4 wires. If you just pull 4 wires to the stats, the sensors, the dampers, everything, you'll be fine. In fact, I would pull 5 wires to everything because I always like to pull 1 extra wire like some of you guys like to do anyway. Here's some of the various part numbers involved, right? So you got the Observer stat, which we've already talked about, or Observer control, excuse me. You have the zoning board, which is required. That's where the dampers and all the sensors are going to wire to. And then you would also have that leaving air temperature sensor that we had mentioned, right? You can either use remote temperature sensors, which is that zone 01 part number down there, or if you want, you can use the Observer control for the zones. Like I said, the dampers are power open, power closed. That's the way you get them from day and night. If you have existing dampers in the ductwork, or you have a favorite Honeywell damper you want to use that's power closed, spring open, you can certainly use that as well. And then generally speaking, we run these off of a 75 VA transformer. That'll handle all 6 of those zones with the 3 dampers each that we talked about. Yeah, if you got a 2 or 3 zone system, you probably don't need 75 VA. You probably need 20, 30, 40 VA. But if you just make it a habit using 75 VA, you'll be covered. In fact, what I would recommend is you use the Honeywell transformer, the AT transformer, because it has that circuit breaker built into it. So if you do something wrong when you're wiring it, you don't have to replace the transformer. You just push the circuit breaker. It's an inexpensive transformer. I've used it for 17 years. It's been great. As far as zone damper sizes go, here are the choices that are available to you from day and night. So you get your typical rounds, 6, 8, 10, 12, 14, 16-inch round. And then you have the choices of rectangular dampers in an 8 by or a 10 by choice. So you got 8 by 10, 14, 18, and 24. And then you got 10 by 10, 10 by 14, 18, and 24. So those are your choices there. There are 2 barometric bypass dampers available, an 8 by 14 and an 8 by 24. And like I said before, we still stock all the Honeywell zone dampers, zoning and bypass. So if you got dampers that are different sizes than available here and you want to use the Honeywell one, you can certainly do that. No problem with mixing and matching those. The one thing you can't do is you can't, on the same zone damper output, you can't mix different types. You can't have a spring-loaded one and a power open, power closed on the same output. But zone 1 could have a certain type, and then zone 2 could have a totally different type. That's fine. All right, I'll see if I can pictorially illustrate everything we just kind of talked about here. So let me see if I can get my little spotlight thing. Hopefully you guys can see this red dot on the screen and everything. So on the left-hand side over here, we have the main observer control. This is the same one we'd use for zoning or non-zoning system. He's also going to be the thermostat for zone number 1, reading the temperatures for that zone. Right? So let's say that's in our dining room or whatever. He is wired with the 4-wire communication cable, 2 wires of communication, 2 wires of power, basically, back to the zoning panel. That same 4-wire communication then goes out to the communicating furnace or fan coil, and then that goes out to the AC or heat pump. And then remember, if you have a 2-stage AC, you only need the yellow and green wires. You don't need the extra 2 wires. The room sensors, in this case zones 2, 3, and 4, also get that same 4-wire communication cable that goes to them. And there's a button on there that you'll press to basically to sync it up so you know which ones are zones 2, 3, and 4. And then the outputs to all the dampers, on our drawing here, we're showing it as 4-wire. In fact, it is only 3 wires that you need. There's a common wire, there's a power open wire, and a power closed wire. However, just to make everything easy and for our marketing folks to say everything is 4 wires, we show it that way on here, right? So if you just run 4 wires to every single thing possible, you're covered. But in reality, the zone dampers only need 3 wires. If you only have 2 wires existing in the wall to an old zoning system, that's fine. You can reuse that, but you would not be using these zone dampers. You'd be using the Honeywell style ones that are power closed, spring open. All right, so that's kind of that example. The other thing you could do is you could say, oops, didn't change screens. I could say, you know what, I want to be able to change my actual temperatures in my rooms, right? So that first example I had, if I want to change the temperature set point for zones 2, 3, or 4, I have to walk back over to zone number 1 and change any of my 4 thermostat settings from that keypad. However, if they say, you know what, in my bedroom I want to be able to change my temperature without having to go all the way back downstairs, or in my basement I want to change the temperature, then instead of putting those non-LCD stats in, you could put in a regular observer control. Obviously, it costs a little bit more money than a non-LCD one. But you could do that, and you'll configure it as a zone sensor instead of configuring it as a main control, and he'll be able to then change settings for that zone. So you're in your master bedroom, the wife yells at you and says, it's freezing in here. You can walk over to the thermostat on the wall in your bedroom and bump that up a few degrees without having to go all the way downstairs. It's the idea behind that. You could also mix and match, right? So maybe you have, in this example, a 4-zone system. And remember, you can do up to 6, so 4 zones is fine. And maybe zone 1 is, in my family room. Zone 3 is in my master bedroom. But zones 2 and zones 4 are my kids' bedrooms, and I don't want them messing around with the thermostat, right? So I can mix and match if I want to and have a mixture of LCD panels and non-LCD sensors on the wall. And then just as a reminder, like I said earlier, you can do this with you can use this zoning system with non-communicating equipment. I don't know that it's that great of an idea. I mean, you might as well just go ahead and use your regular favorite Honeywell panel. But if you want to use Observer on non-communicating equipment, you can do that. But the real power is on the communicating equipment, where I can control the speeds of the variable speed fan. I can control the steps of the modulating gas valve. I can get the error codes from the equipment reported back to me on my screen. That's really why you want to do it. When you want to mix zoning with the power of communicating control, that's when you want to use this Observer communicating system. All right, so here's kind of a summary of where we're at. So if you have the observer communicated control, you can use 4 wires for everything. Like I mentioned, the dampers really only require 3 wires. And like I mentioned, the condensing unit outside, if it's a 2-stage condensing unit and it's communicating, it only requires 2 wires. But if we just tell you to run 4 wires to every single thing, dampers, stats, zone panels, furnaces, condensing units, you're totally covered. Or run the 5-wire thermostat wire like we mentioned earlier, and you're super covered. You got a spare wire for everything. The thermostat itself self-configures when you power it up, which is beautiful. It finds the equipment if it can. If it's non-communicating equipment, it asks you questions. It asks you what accessories you have, and then configures all the airflows and everything related to all the stuff you just answered. It's beautiful. If you haven't seen one before or done one, you should really give it a try, or come to one of our furnace classes in our hands-on lab, and you can see how it works. By the way, we have hands-on labs with day and night furnaces in Melrose Park, Illinois, Lansing, Illinois, and West Dallas, Wisconsin. So any one of those 3 locations, check out one of our furnace classes, and you can really see how these stats self-configure. The condensing unit or heat pump has the outdoor temperature sensor built into it. If it's a communicating piece of equipment, you do not need any extra wires for that. You can relocate it if it's in a bad spot. And if you have non-communicating equipment, you can install a separate outdoor air temperature sensor and wire it back to the furnace. If you have communicating furnaces, fan coils, heat pumps, and condensing units, you get all the error codes brought back to your thermostat in plain text language, plain English, instead of having to count blinking lights. The consumer can change the fan speeds, which is not something you can do with a regular thermostat or a regular zoning system. They can pick, for continuous ventilation, they can pick low, medium, or high fan speed, or they can put it in just auto mode and let it do its own thing. It also has the ability to control dehumidification and slow that blower down. So if the observer control, which has a built-in humidity sensor, senses that the humidity is above your set point, it'll tell the furnace to turn on its blower at a low speed. It'll tell the AC unit to turn on single stage of cooling, and it'll do its best job to dry out that air. As you probably know, if I am able to slow down the blower speed, I am able to get more latent capacity instead of sensible capacity on my cooling cycle, which will help me satisfy the high humidity problem without overcooling the space very much. So it's a very nice feature to have on this variable speed type equipment. And it's all enabled directly through that communication cable on the observer stat. So it's pretty easy to set up. It's pretty easy to wire. It's pretty painless overall. Communicating controls make things simpler. Yeah, if you got single stage furnace, single stage AC, communicating controls aren't that exciting, right? But as things get more complicated, you got modulating gas valves, variable speed fans, 2 stages of cooling, zoning boards and stuff like that. Having all that stuff all happen over 4 wires and self-configure is pretty easy. All right, so that kind of brings us to the end here. If you have more questions, type them in. Don is asking about zone sensor 0101RRS. All right, so while you guys are typing questions in, I'm going to see if I can pull up that manual for Don and answer his question on the fly. But if anybody else has any more questions, please type them in here, and I'm going to stay on the line for a little bit here and try to answer them the best I can. Don, I don't have that manual downloaded on my computer. I'm going to make a note of it here, and I'm going to pull it up after lunch here, and I'm going to get back to you, Don, on the wiring of that sensor. Does anybody else have any other questions they want to type in and see if we can answer them? All right, seems like I got everybody's questions answered so far. And I'm going to go ahead and end the recording and end the webinar. And we'll see you guys next week if you log in next Monday. Thank you.